Hello and welcome back to Compiler Programming. Today I want to work on this issue that I actually opened not so long ago. Basically, right now, if we look at the way that the symbols are handled, they are already somewhat interned, but not much. So we have this thing called scope lookup force that is used to look up a variable or a symbol in a scope. And it already uses a nicer version of a hash lookup where we are also passing the hash already if we know it, instead of just passing the string. But even that thing is actually not really necessary, and it's slower than it can be, because after you look up something in a scope or in a hash map, you still need to do full comparison with the main key, right? You still need to do the string compare, and that's not cheap. So this is what I thought I would fix. There is a very well-known fix for that. So what you do is you go through as you sort of tokenize, instead of recording the strings of symbols, you just assign a unique number to each of the strings, and then you refer to that particular string just by that number. It's called string interning. Here I'm interning the symbols, but the idea is sort of exactly the same. So how do we go about it? Well, first of all, we need to store all this somewhere. So let's create a hash map for that. We will need something like interned. Actually, so yeah, we need a hash map for the tokenization phase. So we can quickly look up if we already have a particular string inside hash map. And for lookups after that, those are just indexes into an array, which should be pretty fast. So yeah, that's how we're gonna do it. We're gonna say interned symbol. Oh, I can't type today. Symbol map key type. That would be a slice, I guess. Yeah, and then we don't even need to provide the function, so just take this, and value type in this case is actually going to be an S64. So we just want to get the symbol index. I'm wondering if it's worth to make it type safe and wrap a 64 in some other type. I mean, why not? It's a good idea to do. So then we will have push type. That will be a struct, actually, and that struct will be symbol index, and a 64 as, or maybe let's do U64, doesn't matter, as U64, something like this. So this is just a wrapper so that we don't accidentally pass a number that is not a symbol index, or we get back a number that's not symbol index. Okay, let's see if that even builds with the changes to the types. Okay, everything seems to be all right. We do need to put this map over to here and say that this is the interned symbol map. And then we need to go to probably here. Yeah, this is where we initialize the compilation, so we also need to add this to here. Interned. I guess it's correctly written. Okay. And we create one of these. Then we have dneed. And then this is the same thing. We just have to destroy it. So this is pretty boring stuff, but necessary to not leak memory like hell. Okay, so that builds. That's great. Let's run the tests. Yeah, so before we run the tests, I wanted to get some measurement. So I have these two sort of big test cases, which is one is 1 million 1 plus 1 operations. So it's just very long 1 plus 1 plus 1 plus 1, so on and so forth. And this is 1 million print calls, which is something I got an idea from Andrew Kelly and Zig, where he was measuring performance of his compiler. So these are current baselines. I don't think we will win much by doing this because majority of time is spent elsewhere. But at least I want to see that there is no regressions, and then I will be pretty happy. If we do win some time, well, that's better. But that's not necessarily the main goal, because if you look at the issue, one of the things I also mentioned is that it opens up some other interesting things I could do, which would be a topic for later videos. Okay, so this is the map. That's fine. Now we need to actually be able to store this somewhere. So here we would say array symbol. I mean, I can actually just store straight up pointers for interned symbols instead of indexes, and then they don't have to look up anything. Yeah, that actually might be easier. Maybe. Let me think about that. Yeah, let's just store straight up pointers. But for pointers, we don't want to use the alt symbol type because that would probably be awkward. Let's store like a symbol new pointer, and fix me rename to symbol when refactoring is done. Okay, so that's like this, and we do need to create that new symbol type, or symbol new. So symbol, oops, wrong thing. Symbol new. Did I copy the right thing? Wait, yes. Symbol new. It has, what does it have? Well, it needs to have a slice, which is name, and I mean, I guess that's it. So maybe I don't even need the type. I just straight up point to slices, but yeah, let's create the type. It's fine. So it's symbol new. Okay. And then I don't need the array. And I think that's about that. Let's try that. Does that build? Yes, it does build. Let's try to run the tests and see if we don't crash anywhere. Okay, that is perfect. Now we are ready to actually start doing stuff. So somewhere in here, we should have symbol cache map. Right. So that's token make symbol. That is the interesting thing for us. So I think we actually will need to change things slightly so that this actually accepts compilation. And then we say compilation cache map. And the reason I'm changing this is because I want to maximally not break stuff. So at first we will put symbols in both places, and then sort of hopefully slowly start to replace the usages of this with other things. Okay, token make symbol. So I guess we also need to change this. Right, and we also need to change headers of all of this. No, we don't. Where is it defined? $11.26. So yeah, that seems fine. Okay, let's first fix these things. They will be fine. Okay, now we need to go to tokenizer and change stuff here. Symbol cache map. Yeah, so we just pass compilation in here. This is unfortunately not regenerated, so yeah, it needs to be in here. Okay, now it's regenerated. Let's see if that helps a bit. So we just have one incompatible type. Yeah, right. That should be like this. Okay, so let's run the tests again. See that I refactored this correctly. It seems so. Perfect. Now we are ready for the next step, which is where we do basically the same thing as we do here, but we store it in a different map. Now that I think about it, we don't even need a different map, because this is sort of exactly what we want, except we are not using, yeah, that is interesting. I think I don't need this, to be honest, because the other one is already doing what we wanted to do. I should have looked more careful at what is happening. Yeah, that's exactly what we want. So we don't need any of that. We need any of that. We don't need that. So, well, it's fine. Sometimes you don't realize that you already done the work ahead of time. So now then the change that needs to actually happen is that we need to change how scope stores the basically, yeah, how scopes work. So right now, if we look at the scope, where are the scopes? Yeah, so scope map key type here is a slice, and what we need to do is change this key type to be symbol pointer, and then hash pointer this function, like so. Okay, so that is better. Now we will obviously have a bunch of errors that we will slowly get rid of. We can do this even, and that's the wrong place. Okay, and we can do const symbol pointer symbol. Right, but we lose the stored hash. I guess that's okay. Well, we'll see. Maybe actually having the hash here is more beneficial than not comparing strings, and I should actually store both the hash and the ID. But that's something for later, I guess. So we can say hash map get scope map and symbol. Does that work? So here we probably have scope lookup. No, we don't. Okay, that's great. Scope lookup shallow. That's well, we don't need hashed version, so we can just remove. Oops, we can remove this one. Lookup hashed also goes away. We will just accept a symbol here. I guess. And yeah, so we still need a different one, but we'll just call it till ID. And here we'll just get the symbol as well. And like so. Okay, that's fine. So entry value name, does that work? Yep, that does work. And here we just do scope lookup shallow. That seems perfectly fine to me. Okay. We do scope lookup. We already pass a symbol here, so that's perfect for us. Good. Okay, so hash. That's fine. Here we do scope hash map hash of. So here we need to pass in the symbol instead of the name. Okay. Oh, this is unhappy with us because we changed the signature. Okay. That's not interesting. Okay, scope lookup shallow. Yeah, so we probably should have a hashed version, but it's fine. Okay, wrap and overload set. And oh, that might be a problem. The way that overloads right now are done. This can be icky, let's just say that. Scope entry, symbol name, hash map set. Nothing really interesting so far. The only thing is overload set might be a bit of an issue, but we'll see if that actually ends up being the problem. So scope define value. Right. So this is where the changes sort of start, because previously we could just provide slices or strings everywhere, and now that's not going to be possible. Instead, we need to essentially, where is this token make symbol? That is not exactly what we would want here. We want to split this into two parts. So the first one is going to be token make symbol value, and in here okay, this is the only place where it's done, and we probably want to just do something like this. Right, and this is now should be split into two parts. One is the part that actually makes a symbol, and another one is the one that wraps it into a value. So this is what it does, and here we should say const symbol is token make symbol of name. Actually no, it's all this stuff: compilation, allocator, name, type, and source range. Right, we don't actually need allocator, but it's something I can clean up later. To take from compilation. Okay. Right, so you need to say const symbol star. Yeah, that's fine. Return symbol. That seems to work. Now let's call it ensure symbol, and let's not call it token. Let's just say mass ensure symbol. This is what it's going to be called. And in here, we would actually already remove the allocator and say compilation allocator. Right, that seems pretty good to me. So now in here we can say const symbol star capture symbol is this. So context compilation capture name. What else we need? We will need source range that is going from somewhere, and symbol type. So symbol type ID like, and then we also need source range, right? So capture view source range. So now in here we define value v is this symbol. Okay, so that seems good. I'm pretty sure we will need to do it in a couple of other places as well. Maybe not. Okay, value args, arg, token per single. Okay, arg name, operator argument names. Store symbols in the operator definition. So for now, I'm just gonna do this. It's not really great, but I added a fix me and I can clean this up later. For now, we'll just pretend that this is a newly created symbol instead of one coming from somewhere else. Actually, in ensure symbol, we don't even need source range, I guess. Let me quickly take a look at this. Yeah, here we don't need source range. Source range is for the value. So that's nice. Index compilation and argine. Okay, so that's good. Let me mark for myself for later to clean this up. Lazy compile time expression. Right. So this is sort of the same type of deal. Me store symbol in the where do we store it? Wait, that's define. So in here we can actually do this const symbol star symbol. We should have symbol definitely in here. Okay. See, so previously we just extract a name, now we'll just pass the whole damn symbol. That's nice. Can we do something like this in here as well? Not really. So the problem is declaration name. It is not a symbol here, so we will need to do the same trick here. But again, that is fine. For now, we are just trying to make this work. Cleaning up is later on. In the function definition. Okay. That seems good. Let's see what we have more. This is the same sort of situation, I guess. What's this? This is a call. Scope define value. Right. So yeah, this is exactly the same situation. But you know, that's okay. Arc symbol like this, right? Yes. Okay. Let's take the next one. Param declaration name. Sadly, that is also the same situation. Param symbol. And we put it in here. Okay. Slice literal apply. Right. So here it is slightly different to do, but in the same vein, where we should have store common compiler symbols. So if we always look up this symbol, then we should generate it before any program is generated. They can just statically have it somewhere in a global namespace and just take it from there, basically. This is what we should be doing. But for now, that's also not a problem. It's just an optimization, so we can skip it. Apply symbol. Okay. Symbol. So slice literal apply. Great, making some progress. Let's continue. Context scope name, that's easy. Here we actually have a symbol. So, we don't need to do anything special for this. Great, let's continue. Here we also actually have a symbol. So again, we actually make the code simpler, not more complicated. Same situation over here. And again here. Right. So this is where we do need to create those, and it's not even fix me because that is actually a declaration, and in declaration you're supposed to create a bunch of symbols. So that's actually perfectly fine. Right. Thanks as well. The compilation. That's gonna break some other things, but if we have to do it, we have to do it. It's always kind of annoying that a lot of the work that goes into making a change is just all of this piping and wiring of data throughout the code instead of actually doing useful work. But I'm not sure exactly how this should be solved. Okay, that's actually not. Okay, one more. Type symbol, that's gonna be this. And okay, seems good. Maybe should have a wrapper function for stuff like this, but that's something again I can think about later. So allocator symbol. Okay. Here we have one for void. And here we have one for type. That should fix that. But we have all of these errors, and they are actually coming from the macro mass defined function that is being auto-generated. So we need to go to that macro and fix it. Mass defined function. Yes, so we need to do something like this. Say that it's a symbol. And do this. Okay. Differs in level of interaction. Cannot convert slice to constant symbol. Right. So we also have this stuff here. Okay. Let's see where there's. Right. So now this is in auto-generated stuff, which is something we can take care of. Mass define function in descriptor type, export if there's something, export global custom name, exports, blah blah blah. Where is the actual thingy that exports them? Generated exports, right? That's what I want. And this is the function that I want. So in here, print scope define, right? Scope define function, scope define. Great. So this is where we need to do the change. We just do it like so. And this would be a bit awkward, but that's fine. So we'll call this stuff send s, and expert name, and comma. Right. So this should be good. Let's see how that works. Yes. Here I'm missing expert name. Okay, we are getting somewhere. The number of errors is now fitting on one screen. Let's see. Okay, first of all here, oops, we actually need to do the following. We need to pass compilation instead of allocator. See where we are having problems. So I guess the issue here is that we need to export this. Yep, that helps. And then in here, right. So this is sort of the same unfortunate situation as we got in here, but for now I'll just do this. That's fine. So we'll call it item symbol, and you're taking this and you're putting this here. Yeah, I probably now should have wrapped this scope define value and left it as it was, but in a sense it is good that we went through all the usages, because majority of them are actually fix me's, right? The majority of stuff here, that's not how it's supposed to be, and there is a bit of generated stuff, but who cares about generated stuff? So returns symbol. Okay, getting warmer. Organizer push symbol. Yeah, so I need to regenerate this stuff. Let's see if that helps. It does, at least for these things. Now we can go and do the next one. So scope define enum, that needs to be fixed. Define enum. Good. Yeah, we don't need source range in here. And we don't need source range in here. Okay. Almost there. So here it's easy. We just do this. And do this. Oh, whatever. Let's put it like this. It doesn't matter. Okay. Well, actually, no, it does matter. Let's do it properly. Let's call this symbol value, or something like, actually, let's do it like this. Const symbol is this. Now we can take this one, we can put this in here, and for the name, we can do it like this. Great. So symbol doesn't have source range. Instead we can do like this. Yeah, this code was a bit awkward, to be honest. So it's good that we cleaned it up a bit. Like this. Okay, now I understand why it was symbol pointer. Okay, fine. Who is next? Right, so this is Debugger. In Debugger, it's perfectly fine to do the most inefficient thing we can do, and that is completely unimportant. So we'll just do this, we'll just do variable name, variable symbol, okay. Do I have any of the interesting data in here? What is exception data even? Exception data, JIT. Oh, we also want compilation here. And compilation is compilation, maybe? Yeah. Oh, I mean, I just edited it. Compilation, great. Okay, so now we can get it from the exception data. Great. And that's good. Who's next? Right. So in the test, it's sort of the same thing. We don't really care about the efficiency of this. So we just say symbol and like so. Here we can do test compilation to make it easier. And then we do symbol here and symbol here. Okay. Global symbol. Have test symbol. And then we look up global again. That seems to be all there is. It is very likely that I made a mistake somewhere, but I guess we'll figure it out when we see this. Let's quickly look at generated code, if it makes sense. Seems to be reasonable, at least to my eye. Let's try to run the tests. I'm pretty sure we'll crash, but maybe miraculously will not. Let's see. Yeah, right. So that is very, very expected in a sense, but maybe not. So interestingly enough, the actual scope tests pass. So if I do get the right objects, then they are looking up correctly. The problem seems to be that we can't really deal with the stuff that is more complicated. So when we define top level functions, this is where we have problems, right? Now let me find some easy function to, yeah, this seems perfect for our case. Undefined variable for, great. So that's what we can look at. Let's open up the debugger and see how we are. Okay. How is this? Actually, we need to go to context, context error, and let's stop here and let's try again. Right. So the error is a defined variable, that's fine. We are trying to look up the symbol in the scope. Okay. First of all, let's actually remove the hash from the name of the symbol struct. That should help make sure that we are not accidentally using that still somewhere and doing weird things. So we'll call this u32 type padding. That's that build. Huh. So at least we do use it. Let's remove that thing. And here. Right. But this is the wrong way to do it. So maybe it's only our tests that are actually broken, not anything else in particular. Let's see if that's actually the case. Because in here we're just creating it on the stack, and that's not great. Test compilation undeclared identifier. Okay, we have even more places where this is not correct. Yeah, good that I removed that hash, because that, I think, saved me a lot of the debugging headache. It is like this. Good. Let's try again and see if that helped. And at least for that test, it definitely helped. Let's see all the other ones. So for that, I need to go back and undo the focus of the test. And let's see how that goes. Oop. I definitely don't know how I did that. Yes, close all tabs. Let's get back. Okay, that is not good. We are very much crashing somewhere. Let's see what's happening. So calculate match score argument, same type. Um, Well, there would be problems with overloads, but I'm a bit surprised this is happening in this test. Let's disable this first test for now. See if we can get further. Actually, those two are working just fine, right? This the next one that is failing. Okay, and the next one is failing. I wonder what is the actual cause. Probably the issue here is that when we have arguments in a function, so I would assume this also fails. No, that doesn't fail. That's interesting. So how does the structured exception look like? Oh, I guess where we have operators. This is the issue that we would be having. Okay. Let's find an operator. It's minus. Do you work? No. Okay, so yeah, it seems to be the issue with operators. And that should narrow down the problem, I hope. Handle function call. Args you. Great. Descriptor, descriptor. Descriptor. Pointer to. Okay. The args is fine. It's our overload matching that is not doing so hot. So match argument score, args, overload info. And the problem is that param declaration descriptor is null. Okay. And I guess argindex, so argindex is 1, which is not what I would expect. So generic one worked just fine, but this runtime has a problem with the declaration. Okay. How do I debug this? That is an interesting question. Parameters. Okay. Fine. Equals. So we have here context, declaration, context, descriptor. So this seems okay. I mean, we assign descriptor straight away, and that's the only parameters that we get. That's kind of not true. Temp params, great. So I guess that's where the issue is. So let's do this. Let's see how we're doing. Fine. Fine, fine. So what is param here? Generic. That's okay. We want the next one. Param. Generic. Param runtime. Yeah, that seems like the one that we want. Param runtime. Yeah, descriptor is 0. So let's restart that. Run. 2. And param view. No. Yes, this is the one that we want. Okay, let's go inside. We go here. Go here. Go here. Okay, great. Descriptor starts at 0. It's generic. It should not be generic. Come on, show me if it's generic. Yeah, it's not generic. Fine. So name token. It is a symbol. All is great so far. And descriptor is null. Wait a second. That's strange. Oh, how did that work exactly before, I wonder? I feel like that was a bug. Because in here, I mean, in this branch, we really don't set it to anything. So if this is like this and it's matched, fine. But otherwise, it is null. Oh. So we have a type expression. That's fine. And here, 0 is 1. Yeah, it's a value. Well, it's a symbol, but it's kind of expected. I'm slightly confused about this, to be honest. What can we do? Well, I guess what we can do is to stash this, and in here go to 1954, and in here we'll just say assert descriptor, generic or descriptor. So if it is generic, yes, we shouldn't get the descriptor, but if it's not generic, then I would expect to get the descriptor. Oh, I think now I start to remember that this is done So you can wait a second. No, this case should be like this. Let's try that. I think it will crash, but we'll see. Yeah, so that assertion is failed. Actually, now I think I remember, right? Yeah. So we have this maybe type expression. Yes, here. And then we are trying to do some stuff with it. So this is a return, yeah. Token match type, yeah. So actually here's where things should happen. So git stash pop. Guess I screwed up this somehow. Do assert here. This is where it's supposed to be. And obviously that will fail. But then we can go from there and try to figure out what's going on. Well, that is very interesting. So is it this then? No, here we already have an assert. Okay. Now I'm very confused. Oh, okay, let's just try to look in here and make a stop and see what's going on. Whoop, I don't want to search online, definitely. So what is the param? Param. Okay, so yeah, this is actually the one that failed. Time context, maybe type expression, and context results. Undefined variable. Okay, so actually we have undefined variable as a problem, and it's just manifesting as a crash because somewhere in here, that's fine. That's fine. Yeah, in here we should do a different thing. So go to 3764. Right. This is where okay. That is actually slightly awkward because we don't really expect this to fail, but it definitely does. Yeah, it's the function info and function literal for args, literal, blah blah blah. So mass on error context result return 0, and then in here If not, overload info return. So that should stop us from crashing, but we should still get the error that the type is not found. Okay. It's not exactly what I wanted to happen. So I guess well, it's fine, I guess. And that's something I can look into later. This is not really related to what we're doing right now anyway. So what is actually a problem is that we cannot find the type, which is not a mystery because I can't even find that string in here. So I think I just copy pasted the wrong thing somewhere, and this is the source of our problems. Allocator symbol, yes. Built-ins, yep. So that would explain it. That would definitely explain it. Now we have type in here. Let's see if that helps. It does for this test. Let's see if that is all that was actually broken. If that would be it, that would be awesome. Look at that. We are perfect. So let's commit this. 176, and let's say interned scope symbols. Great. And we can actually see if that what they did to performance. I mean, there is a bunch of fix me where we are doing a lot of unnecessary work, but even with that work, we probably are okay. Let's actually see if that is the case or not. Release bed, okay, and now we can do measure. So we are about the same. That is great for print. Let's do folding. I think we are about the same here. Maybe just a fraction faster. I think it was 225 or something like this. You can go to the beginning of the video and check if you want. But yeah, so that is basically what I want to do. Of course, there is a bunch of stuff to clean up, but that's something I can definitely take care of offline. And the most important thing that this feature is now there, and you can look forward to, I think, quite an interesting video on how we're gonna use this to solve some of the issues that come up with languages and solved usually with stuff like interfaces and such. So yeah, I'm quite excited about working on the next thing, but that is definitely next time. For now, thank you very much for watching, and hopefully see you then.